So we factorize the left side of the inequality, and in doing so we have to multiply the first term and the last term to get 4x squared, and then you look for two factors of this number such that when you add them it will give you 3x. So two factors of this number, if we use 4x and negative x, when I multiply this I will get this back, and when I add this I will get 3x. So I will substitute in place of 3x 4x minus x. So we have x squared plus 4x minus x minus 4 is less or equal to 0. So I factorize x plus 4 minus 1 x plus 4 is less or equal to 0. So we'll be having x minus 1 and x plus 4 is less or equal to 0. So now we apply our rule. Remember, if a, b is less than 0, it means that a is less than 0 and b is greater than 0, or a is greater than 0 and b is less than 0. So in this case, x minus 1 will be my a, x plus 4 will be my b. So that implies that x minus 1 is less or equal to 0 and x plus 4 is greater or equal to 0. In this case, x is less or equal to 1 and x is greater or equal to negative 4, or x minus 1 is greater or equal to 0 and x plus 4 is less or equal to 0, and x is greater or equal to 1 and x is less or equal to negative 4. So you see, it's not possible for us to have x to be greater than 1 and at the same time x to be less than 4. So this is not possible, okay? This is not possible, okay? Okay, so the only solution is x less or equal to 1 and x greater or equal to negative 4. We can write this as a single expression as negative 4 is less, since x is greater than negative 4, it means negative 4 is less or equal to x and x is less or equal to 1. Okay, so that our interval notation will begin from, remember, a box bracket, negative 4 is the least number, and to 1, another box bracket. On a number line, we represent this. On a number line, if we are having negative 4, which will come first, negative 4, okay, because it is a closed interval, it will be a solid dot here. If we have a negative 1 itself to be here, because also is a closed bracket, is a closed interval, we have a solid dot. So the values of x are all values that are greater than negative 4 in that direction, and again all values that are less than negative 1, okay, will represent values of x. So this is the intersection of those two sets of values of x. So number 3 we have x squared minus 2x minus 3 is greater or equal to 0. So again, the first term multiplied by the last term is giving me negative 3x squared, and two factors that will give me this two factors of negative 3x squared that when I add together I will get the middle term could be let's say 3x and negative x. Okay, 3x and negative, no, that should be negative 3 and x, negative 3 and x. So in place of minus 2x, I will put in negative 3 and x. So the equation inequality becomes x squared minus 3x plus x minus 3 is greater or equal to 0. So when I factorize, I'm going to have x minus 3, and this will give me plus x plus 1, plus 1 x minus 3 is greater or equal to 0. So we'll be having x plus 1 and x minus 3 to be greater or equal to 0. And then applying our rule again, remember if a, b is greater or equal to 0, it means that a is greater or equal to 0 and b is also greater or equal to 0, or a is less or equal to 0 and b is less or equal to 0. Okay, so in this case, remember, this will serve as my a and this will serve as my b. So we'll be having x plus 1 is greater or equal to 0 and x minus 3 is greater or equal to 0. So in this case, we're having x is greater or equal to negative 1 and x is greater or equal to 3, or we do the other way, less than. Before we do that, look at this expression. We can write this as a single statement, which will just be x is greater or equal to 3. Since x is greater or equal to minus 1, also implies that since x is greater or equal to 3, also implies that x is greater or equal to negative 1. So we can use this as a single statement to represent both of them. So or x plus 1 is less or equal to 0 and x minus 3 is less or equal to 0. So in this case, we're having x is less or equal to negative 1 and x is less or equal to positive 3. Okay, in which case we can just represent both inequalities as a single statement by just saying x is less or equal to negative 1, since that also implies that x must be less or equal to is also less than 3. Okay, so this is the single statement for these two inequalities, and this also is a single statement for these other two inequalities. So we can represent this on a number line as follows. Okay, when we say x is all numbers that are less than 1, so if this is negative 1, it follows that a solid dot, negative 1 inclusive, are all values of x that are less than